Welcome to this explainer. Today, we're tackling a massive challenge, one that honestly keeps a lot of front-end and edge developers awake at night. We're talking about building complex, local-first AI applications without letting your codebase degrade into a chaotic, untestable mess. Look, if you've ever stared at a screen full of tangled component logic at 2 a.m., you know exactly what I mean. Think of our goal today through the visual metaphor of earth tones and floral highlights. We are trying to bring a real sense of organic, structured peace to what is usually a very noisy, chaotic environment.
So, the million-dollar question, right? How do you actually build a complex edge agent without creating a monolithic, untested mess? This is absolutely the central architectural question haunting local-first AI development right now. Because when you're building an edge agent, you aren't just making standard API calls. No way. You're wrangling real-time streaming LLM responses, local SQLite databases, offline first sync engines, and hardware APIs like the microphone, literally all at the same time. And if you aren't super careful, the logic managing all of that gets tangled right into your user interface. That's exactly the trap we're going to solve today.
Okay, let's dive right into our roadmap for today. We've got 6 parts: the edge complexity trap, finding Zen with XState, sequential flows with the auth machine, optimistic rollbacks with the character machine, the 3-layer architecture, and finally, testable edge agent loops. Let's get going.
Section 1. The edge complexity trap. We're looking at the very real danger of giant React hooks.
If you've ever built React Native apps, you know the exact pain point I'm talking about. You start out simple, right? Maybe just a single is-I-loading Boolean and a hook. But then you add AI streaming, so now you need an is-streaming flag. Then you add offline support, so throw in is-offline. Before you know it, you're relying on a giant, monstrous use effect filled with a dozen Boolean flags. This monolithic hook approach is so brittle. It creates these weird implicit states where somehow is-I-loading and is-error might both be true at the same time, which makes absolutely no sense. Plus, it's a total nightmare to test because you have to mock an entire UI lifecycle just to check one simple logic branch. On the flip side, we have the solution: explicit state management using XState version 5. This approach gives us highly testable, completely decoupled logic.
Moving to Section 2, finding Zen with XState. This is a massive paradigm shift for React Native.
So what is it? A state machine is basically just a mathematical model of computation with explicit, strictly defined states. The rule is simple. You can only be in one state at a time. You're either loading, or you're idle, or you're in an error state. By shifting complex asynchronous flows completely out of our React hooks and moving them into these state machines, we bring a profound structured piece to our edge agent architecture. It's kind of like replacing a massive tangled ball of yarn with a crystal clear flowchart that your code actually has to obey. And that means far fewer midnight debugging sessions for you.
And this brilliantly illustrates when to actually make the jump. The Clanker source material gives us a fantastic rule of thumb here. You obviously don't need a state machine for a simple toggle switch, but the second you're dealing with multiple sequential async steps, or optimistic UI updates that might need to roll back, or long-running background work, like an AI indexing documents in local SQLite, you need a machine. Basically, if you have complex conditional transitions, or explicit loading, idle, error, and success states that require isolated testing, that is exactly when you reach for XState.
Section 3, sequential flows. Let's look at bootstrapping safely with the auth machine.
Authentication in a local-first AI app is rarely just checking a single token. In Clanker, for instance, the auth machine has to handle a pretty complex sequence safely. First up, it enters a bootstrapping state where it waits for Firebase to resolve the core identity. But it doesn't stop there. It then has to fetch the user's specific application state and their subscription tier from a Cloud SQL backend. Only after all of that succeeds does the machine explicitly transition to authenticated. Or, if any single step fails, it drops to signed out. There's not a single Boolean flag managing this sequence. It's a strict, unbreakable flow that guarantees your UI will never, ever render an authenticated screen before the underlying user data is actually ready.
Part 4, optimistic rollbacks. Safe, offline-first UI updates with the character machine.
Let's move to the character machine and see how this builds on that idea to create a flawless user experience. This machine manages character creation and edits. Because this is a local-first app, when a user edits an AI character's traits, the UI needs to feel instantly responsive, right? So the machine immediately updates the UI optimistically. Then, in the background, it attempts the async database write to the local expo-SQLite database. If that write succeeds, awesome, the state is confirmed. But if it fails, the machine automatically executes a safe rollback. Because the machine explicitly remembers what the state was before the edit, it can revert the UI flawlessly without you having to write any messy, bug-prone cleanup code inside a React hook.
Section 5. The three-layer architecture. Decoupling real-time voice and logic.
Now, what's really interesting about this is how Clanker uses a distinct three-layer design pattern for its real-time voice features to strictly divide responsibilities. At the top, you've got the UI layer. It does nothing but render the screen and capture user taps. Below that is the hook layer. This is where you have a controller hook wiring things up to a dedicated hardware hook, like useLiveAudioIO, which strictly handles the microphone and speakers. And finally, at the very bottom, completely isolated from React, is the core machine layer. This uses an XState machine, like the liveVoiceMachine, to orchestrate the actual speech-to-text results, the prompt building, and the LLM logic. This absolute separation ensures that your hardware constraints never dictate your core business logic.
To really understand why this three-layer pattern is a game changer, think about what happens if a user simply navigates away from the voice screen mid-sentence. If all your logic was stuffed into one component, you'd almost certainly get a memory leak, or the AI's audio would just keep playing over a totally different screen. Yikes. But with this setup, your hardware hook, useLiveAudioIO, is exclusively managing the mic and speaker lifecycles. If that UI component unmounts, the hook instantly stops the audio player and releases the hardware. Done. Meanwhile, underneath it all, the liveVoiceMachine allows that in-flight AI network request to actually finish and save to the local database so your chat history stays completely consistent. But the hook guarantees no audio plays on a dead screen. It really is just a beautiful separation of concerns.
And finally, Section 6. Testable Edge Agent Loops. This is the real developer experience payoff.
This entire architectural approach, extracting complex logic into XState machines and using a strict three-layer pattern for hardware and UI, it literally gives you superpowers as a developer. You entirely avoid monolithic spaghetti code, your core business logic becomes incredibly testable. Think about it. You can instantiate that liveVoiceMachine right in a Jest test without needing to mock an entire React DOM or native hardware modules. That dramatically increases your velocity because your tests just run instantly in Node. You get explicit loading and error states basically for free. You get resilient offline-first capabilities for local SQLite writes and optimistic rollbacks. Ultimately, it delivers a Zen-like developer experience where you actually trust your code to do exactly what it says it's going to do.
So, the crucial point I want to leave you with is this. If you're building an AI app and your LLM orchestration, your hardware APIs, and your database writes are all just living inside a React component, you are sitting on a ticking time bomb of complexity. Take a hard look at your own codebase. Is your edge agent's logic currently trapped in the UI? Because if it is, it might just be time to extract it, find some structured piece, and embrace the machine. Thank you so much for joining me for this explainer, and as always, happy coding.